In this video, we're just taking a quick look at matrices. So, where are they used? I'll just let you guys read it rather than me reading it all out to you. So essentially, pretty much anywhere where there's computation going on, matrices are involved. They're used a lot in weather forecasting, anywhere where essentially there's large quantities of data being manipulated. Matrices are a very compact way of storing large quantities of information. So just some of the things we need to be able to do. I'll go through these. We'll really just be defining matrices in this video, and then in later videos we'll be doing some of the more complex stuff. Yeah, this will be a video in itself. Inverses will be a video, and row operations will probably be a video. So, formally, a matrix is a rectangular array of elements with m rows and n columns. Always, guys, it's vital, rows are always first. Whenever we're talking matrices, it's rows first and then columns. So this is what a matrix looks like. Now in the next slide we'll talk about the general naming and stuff, but if we're talking about a matrix in general, it gets a capital, and then each element within the matrix is given by the small letter. So if it's capital A is the matrix, then each element is called small a. And then these little subscripts describe the row and the column. They're the position. So here A32 is row 3, column 2. A24, row 2, column 4. So it's like a little grid marker as to where each element exists. And again, it's m number of rows and n number of columns. And now a matrix is usually defined by its size, which is called its order. So you could have an m by n matrix. Remember, m is the rows, n is the columns. Or else you could say of order m by n. And again, this will make sense very shortly. So here, guys, we have a matrix. It's got 3 rows and 1 column. So it's a 3 by 1 matrix. Rows first, columns second. It's also called a column matrix because it forms a column. And this matrix here is called a row matrix because it just forms a single row. There's 1 row, but there's 4 columns. So that's a 1 by 4 matrix. Here we have a square matrix. We can see it's got 4 rows and 4 columns. So that's a square 4 by 4 matrix. So we just take a look at a few more, make sure you have your head around them. I'll allow you decide what's the order of this matrix. Number of rows first, then number of columns. It's a 2 by 3. 3 by 2. This is a row matrix, 1 by 5. And here, quick count, 5 by 3 matrix. So that's what we mean by the order of the matrix. And again, I can't emphasize it enough, always rows first and then columns. Now we're only going to introduce the identity matrix here. So the identity matrix, first of all, it must be square. All the elements on the main diagonal are 1 and every other element is 0. And that's what forms an identity matrix which is called I. So here we have I2, and the 2 just means it's, by definition, it's a square matrix. So the 2 just means there's 2 rows, 2 columns. Here we have 1s on the main diagonal, and everything else is a 0. Here we have I3, 3 by 3 matrix. Again, the main diagonal starts in the top left and works its way down to the bottom right. So there's 1s on the main diagonal, and everything else is a 0. And then it goes on, there's I4, I5, as big as you want really. Now the main property of identity matrix, and we'll only introduce this at the moment and then we'll come back to it in later videos, is that any matrix multiplied by an identity matrix is itself. So if I have the matrix A and I multiply it by an identity matrix, I'm going to end up with the matrix A. Doesn't matter if I multiply the identity first, I'm still going to get the matrix A. So that's a very important property. And at the moment we'll just introduce the concept and we'll come back to it later again. So any matrix, when it's multiplied by the identity, the answer is the original matrix. Transpose of a matrix. So what happens here is the rows and the columns of a matrix are swapped. What was a row becomes a column. So say if we have a 3 by 2 matrix, I'll do a few examples in a minute. So here's a 3 by 2 matrix, just imagine there's numbers in there, we'll just call it matrix A. The transpose of A gets a little superscript of T, is going to be each row, so there's the first row, becomes the first column. The second row becomes the second column, and the third row becomes the third column. So here we have a 3 by 2 matrix. When we transpose it, first of all the positions are changed, and then we end up with a 2 by 3 matrix. So that's what essentially happens. The rows and the columns are interchanged. The matrix is transposed. So here we have a matrix A, and we can see here's the first row. Well, AT, here's my first row, 3, 1. That's going to become my first column. The second row, 2 minus 1, becomes my second column. And the third row, 4 minus 7, becomes my third column. Similarly, again, first row becomes the first column. Second row, 7, 1, 0, minus 1. And the third row, 3, 5, 1. So here we have a 3 by 3 matrix, and when we transpose a square matrix, it's still going to be 3 by 3. Just double checking I haven't made any mistakes there. 6 minus 4, 6, 2, 7, 1. Yep, that looks okay. And there's our matrix there. So it's quite easy to make a mistake when you're doing the transpose, so just take your time and try and avoid errors, because any small mistake made in a matrix unfortunately compounds itself very, very quickly as we work our way through. So the calculations involved in matrices are actually very simple. Unfortunately, you're doing large quantities of very simple calculations, so the potential for error is considerable. So finally then, guys, just in general, when you multiply a matrix by a constant, so here we have a matrix A, it's been multiplied by a constant. What simply says is the K gets multiplied. Each element within the matrix is multiplied by the constant. So again, best explained by example. Here we have the matrix A. It's been multiplied by 3, and simply every element is multiplied by 3. And that's all we're saying in this one. In this video, we're going to take a look at the basic operations and apply them to matrices. So adding, subtracting, and multiplying matrices. So adding and subtracting are generally straightforward. The one condition is, though, the two matrices, they must be of the same order. They must have the same number of rows and the same number of columns. They must be the same shape. So a 3 by 2 matrix can only be added or subtracted with another 3 by 2 matrix. And once we see the method, it becomes obvious why. The reason is, guys, is you simply, if we're adding two matrices, we simply add the top left elements and our answer goes in the top left. We add the top right elements and our answer goes in the top right. Add the bottom left elements and add the bottom right elements. And there's our answer. And the same then for subtraction, but again, watch out for the minus, especially where there's minuses inside the matrices as well. So here we have 1 minus minus 1. So that's 1 plus 1, which gives us 2. We have 2 minus minus 3, which gives us 5. 3 minus 0 is just 3, and then we have 4 minus 3 gives us 1. And there's our answer. So that's adding and subtraction matrices. I'm not really going to spend too much more time on them. I think it's fairly straightforward. Just watch the minuses when you're subtracting. Now we're going to take a look at multiplication, and multiplication can be quite tricky. The maths is straightforward, just making sure you do all the sequences correctly without error is the challenge. So first of all, they must be of compatible orders. So this is not the same as the same order. They don't have to be the same shape. But what they must have is, if we're multiplying two matrices A by B, the number of columns in B. So the order of matrix A is row by columns, and the order of matrix B is also rows by columns. So the number of columns in the first matrix must equal the number of rows. That's what we mean by compatible. So that's the condition, that the columns in the first matrix, the number of columns in the first matrix must equal the number of rows in the second matrix. Now, what's important as well is our answer, C. The order of my answer is actually the rows of A multiplied by the columns of B. So these, in this case, are going to be the order. I'll just say R1 by C2, C1, R1. So in this case, the order of this matrix, the resultant matrix, is going to be R1 by C2. And again, I'll explain by example as we go along. So that's very important, guys, this idea that these ones must be equal. If they're not equal, you can't multiply them, and you can just simply stop there and say the matrix BA or AB, whatever is required, is not defined. I can't do it if these two are not equal. And if they are equal, then the order of my resultant matrix C is the rows in A multiplied by the columns in C. So this is just putting words on what I was saying there. I won't go over it again. So say if we're multiplying these two matrices. On the left, we have a 3 by 2 matrix. And it's been multiplied by a 2 by 1 matrix. So now, the columns in the first one must equal the rows in the second matrix, which they do. So now we know that we can multiply these and we will achieve an answer. The size of my resultant matrix is going to be a 3 by 1 matrix. And that looks like this. So that's the kind of conditions, that's how you confirm. And often in the journals I'll ask you to multiply two matrices and they're not compatible, and you just simply say AB or whatever you're looking for is not defined. There's no way you can achieve an answer, so you don't even try. So now we're going to take a look at the nuts and bolts of what goes on inside the matrices when we're multiplying them. Essentially, guys, this top element here is achieved by the top row multiplied by that column. Then we'll multiply the next row by the column again, and that gives us this, and then we multiply the third row by this column, and that gives us the third element. So this is why the number of columns, there must be 2 columns in order to multiply into the 2 rows. That's why these figures here must be the same. So we'll take a look using numbers. So the elements in the top row of the matrix on the left are multiplied by the elements in the left column of the matrix on the right. Once you see a few done, it'll make sense. So here I've only included the numbers of the top row, just to avoid confusion. So I know my answer from earlier is going to be a 3 by 1. Here we have a 3 by 2 matrix. It's been multiplied by a 2 by 1 matrix. So I know my answer is going to be a 3 by 1 matrix. There's going to be 3 answers in there. Now the top answer is got by the top row multiplied by this column. So the first element in the top row, the 1 is multiplied by the first element in the column, 1 by 3, plus the second element multiplied by the second element. So we're going to have 1 by 3 plus 2 by 4. So I'll just write that neatly. And now you simply do the maths. We'll get 3 in the left hand bracket, 8 in the right hand bracket. They add together to give us 11. And then, guys, if we know the values in here, which you usually will, then you multiply this value by 3, this value by 4, and that gives you your answer here. Add those. And again then for the third row. So in the next slide we'll just take a look at a concrete example. So we're asked to determine the matrix A by B. So this is what we're looking for. Now on the left, matrix A is a 2 by 3. Matrix B is a 3 by 2. So my answer is going to be a 2 by 2 matrix. So each of those dots represents an answer. I don't know what those answers are yet. So now we take a look at the nitty-gritty of it. So now, I always label these. So I know I'm looking for 4 answers in here. And I simply label them by their position. Top left, top right, bottom left, bottom right. And I'm going to show you how to achieve each answer. And each answer requires a little bit of maths. So top left, guys, the names actually tell you what to do. It's the top row multiplied by the left hand column. So the top row multiplied by the left hand column. When we do the maths, 1 by -3 plus 2 minus 3. And when we add these together, we get -4. Now, top right. That's the top row by the right hand column. So now again, top row, first element is multiplied by the first element in the column, 1 by 2. Second element multiplied by the second element, 2 by 5. And finally, third element by third element, 3 by 2. So we just go 2 plus 10 plus 6. And that gives us 18. Bottom left, same process, but now it's the bottom row by the left hand column. Again, -1 by -3, that's +3. 0 by 1, that's 0. And then 4 by -1, that's -4. So 3 minus 4 gives me -1. And finally then, bottom right, bottom row by right hand column. So the name tells you what you're looking for. I'm looking for the bottom right element, bottom row, right hand column. Same idea, -2 plus 0 plus 8. So -2 plus 8 leaves us with 6. And there's my resultant matrix there. So now we'll just take a look at another one. It's the same two matrices, A and B. But now we're asked to calculate B by A. So the order of the calculation is essential, guys. This is a completely different problem, as we'll see. We're asked to get B by A. B is a 3 by 2. A is a 2 by 3. But again, the columns in the columns in B, the columns in the first one equals the rows in the second one. So that means I can do the problem. I know there's an answer. And my resultant matrix is going to be a 3 by 3, which is going to look like this. So now we'll take a look at the maths. Just as I said, this is what we're looking for. So there's 9 elements. Top left, top middle, top right, middle left, middle middle, middle right, bottom left, bottom middle, bottom right. We're going to look for each one individually, and you've got to be organized, guys, in doing these. So I always lay them out like this. I start literally top left, top middle, top right in a row. Top left, top row, left hand column. And we get -5. Sorry, I'll just put that up again for a second. So it's -3 by 1 plus 2 by -1. So -3 plus -2 gives us -5. Now we look at top middle, top row, middle column. Top row -3 by 2, and then plus 2 by 0. So that gives us -6. -6 plus 0 gives us -6. And now we take a look at the top right. Top row by the right hand column. -3 by 3 plus 2 by 4. So -9 plus 8 leaves us with -1. And now we continue, guys, except now we multiply the middle row by each of the 3 columns, and then the bottom row again by each of the 3 columns. So that's what's on the next slide. Middle left, middle row. So 1 by 1 is 1, -5, which leaves me with minus 4. Middle, middle, middle row, middle column. I've got 2 plus 0. Leaves me with 2. And finally, middle right completes the middle row. We get 3 plus 20. So that gives me 23. So now I'm 2/3 of the way through my matrix. So as I said earlier, the maths is quite straightforward, but it's just keeping everything nice and tidy. Lay out your work carefully. Bottom left, bottom row, left hand column. So here we have -1 plus -2. So that's going to give me -3. Bottom middle, and it does get a bit confusing, but as long as you kind of stay focused, you'll be okay. We have -2 plus 0, which is -2. And finally then, guys, bottom right, bottom row, by right hand column, we get -3 plus 8, so that gives us +5. And now we have completed our matrix, and this is our resultant. So that, guys, kind of concludes just this video on the basic operations of matrices. So thank you for listening.